Hello and welcome to Industries Helping Hands. We welcome you to the Talk with Industry Expert session, where in this video we are going to have a conversation with an electric vehicle industry leader, Mr. Sathees Chandran, CEO of an electric vehicle company, Zitto Motors. He has a successful track record in his educational journey. After completing his graduation, he has done his Masters of Technical Education from the different universities across the world, which include his learning of automotive engineering and technology from the University of Deusto, Spain, from University de Bordeaux, France, from Loughborough University, UK, and from the University of Antwerp, Belgium. He worked at world's biggest company of electric vehicles, Tesla also. The great aim of education and experience is knowledge along with the action, and the best way to predict the future is to create it. He formed the company for the electric vehicles, Zitto Motors. In this talk session, the student community is directly going to learn from the CEO of the company about how to prepare yourself to become job ready for the EV industry. From how to write a resume to how to get the offer letter. Everything we are going to cover in this talk session. If you want to know more updates regarding the electric vehicle courses, then you can visit our website industrieshelpinghands.com, and you can also download our mobile application. For more updates, you can join our WhatsApp group and Telegram channel. The link is in the description. Press the subscribe button to never miss any update on YouTube. So let's unlock the knowledge in this session.
So, yeah, recruiting, every recruiter must be going through hundreds of, maybe thousands of CVs. So, recruiting is very vital to any company. And often candidates get rejected, not just freshers. In general, candidates get rejected just because they couldn't stand out from the crowd. The CV is nothing special there. It's all the same format. You have the same set of wordings, and it just doesn't stand out. So CVs are essentially your first impression that you can make to a company. You're not meeting anyone first. You're essentially sending the CV and expecting them to have a picture of you as a person. So make sure that CV stands out. So I would tell you a fact about the industry right now. This is one of those rare opportunities where 20 years of experience in an OEM, in an ICE engine OEM, and 3 years of experience in an EV almost would be make you equal in terms of joining the EV industry, which is a weird time, but that is a fact. So try to get into try to take up any opportunity that comes to you for learning instead of trying to settle immediately after your studies. Most people want to just get into any sort of job and not even related to what they have studied. I've seen students finishing mechanical engineering, then abandoning the whole logic and dream of being a mechanical engineer, and then going behind IT and getting the job. They work for a few years there. By the time they got settled in that one, they basically cannot escape. They are stuck there. They essentially do not remember what they studied as part of mechanical. And essentially from that point, coming back to mechanical, identifying a job becomes very tedious. So what they do is they follow that journey of as an IT professional and do that job there.
Hello and welcome to the Talk with Industry Expert session. And today we are having with us our very special guest, one of the dynamic leader of the electric vehicle industry, Mr. Chandan Sathees, sir. So basically, sir, a very warm welcome to you on our platform, and you're willing to help the student makes you a different personality. So thank you so much for joining us today, sir.
Thanks for inviting me. Glad to be with Industry Helping Hands.
And along with him, we are having Mr. Ashish Karu, sir, Project Head of Electric Vehicle Courses and Industries Helping Hands. So I would like to say to our student community across India, this session is going to be very fruitful for them because Chandan sir is first a great academician before an industry leader, because in his entire journey of entrepreneurship before he started, he gave much of the importance towards the education. After his BTech, he completed his masters from the different universities, which includes University of Deusto, Loughborough University, and University of Bordeaux, University of Antwerp. So after taking lots of technical knowledge, he's even still not stopped and completed his MBA in Business and Operations from the NMIMS Global. So it's a whole long journey of learning, and still he is learning. And with a day-to-day experience as a founder, CEO of the company of Zitto Motors, Zitto EV, one of the best company that is doing work on the EV segment. And his work experience also includes his starting work from whether it's TCS, where he was a service engineer, then he worked on an internship in the powertrain also, then he was in the Tesla, then KWH bikes, and after all the sort of learning from the institution and from the industry, he started his own venture, Zitto Motors Electric Vehicle Company. So it's an amazing journey, sir, you are having. As you have told me that your journey has just started. It's a way to go. It's a long journey that you have to cover. But I would like to know that, sir, how the things come in your mind, because from the beginning itself, you are very curious about the electric vehicles. So how these things happen with you? I would like to know that.
Yeah, so this whole plan of starting own company started from college life, bachelor's itself, but not an EV company. I had several plans of different companies to start with, but it's you need someone to be a supporting hand or with some technical knowledge, some management knowledge. And I was always waiting for that kind of people who I could associate with. And now it's the right opportunity. Working with startup like AWH, I got connected with a lot of people who are currently in the startup industry. And I got to understand this space much better. And I thought like this is the right time to enter. And EVs being my specialty, I wanted to start in EVs.
That's absolutely amazing. And your journey is like a complete syllabus of a book where each and every chapter is of a learning experience for the students. So I would like to know that, sir, it's a time for the electric vehicle revolution. EVs are at the cusp of the mobility. It helps in transforming the mobility of India. So how you see these changes and what kind of opportunities it is creating in the Indian ecosystem? I would like to know your views on it, sir.
Okay, so EVs and IC engines essentially are not new. People think that it sort of started the last decade, but it's not. It's almost a century old technology. And currently, we are at sort of the point of no return for EVs. So, for an example, I would say imagine a flight taking off from a runway. On the runway, there is a specific point beyond which the pilots are not allowed to abort the takeoff. They are supposed to take off irrespective of engine failure or some technical issue. So EVs have reached that phase where there is no return. Even if the petrol prices come down, or we identify a new engine with say 50% thermal efficiency, it's just not going to stop. The movement is already started, and it took 100 years essentially to do it. And the reason was EVs and IC engines almost were of same popularity a while back, 100 years ago. There were EVs that could do 100 kilometers of range at that time. And then the World War happened, and it sort of changed the whole spectrum. And IC engines being capable of charging immediately, filling up, and you can just keep on going, became the norm. And everything associated with the war essentially helped IC engines become part and parcel of everyone's life. And I believe that's how the EVs got forgotten for the next 80 to 90 years. And then it took a significant amount of engineering know-how, especially in terms of battery, because other technologies like the motor sort of existed, and we were able to develop it further because there were other applications in which motors and so on were used. But batteries had to be changed from lead acid to lithium-ion batteries, wherein the weight made a lot of sense, because lead acid, to get the same performance, you would have to have significant amount of weight involved in it. So when that transition happened, now we are at a phase where this is happening so fast. Like we are switching from IC engines to EVs. In terms of India, not just India, around the world, I believe this transition is going on, even to countries like countries in Africa. So the transition is happening across the globe, and for India also, we are seeing this change right now. We have vehicles that can do 400 kilometer plus in Tata Nexons and MGs, ZS EV. We have Tesla, who was interested for a while in joining the Indian market. We have motorcycles which are already pushing 150. So it's just a matter of time before we we go completely towards this transformation. It's not an immediate process. I will not say. It's not like IC engine vehicles will cease to exist tomorrow. There will be IC engine vehicles for the next 50 years in different formats in different places. For example, if it's a ship, you are not going to get IC engines off it for a long time. Large aircraft, you cannot get them completely on unless you have some great breakthrough in battery technology, which completely revolutionized everything. With the current technology, we are seeing another 30, 40 years for a transformation. So government together with the OEMs need to work on this one together if you want to accelerate this transition. So infrastructure like the charging stations and the OEMs essentially need to work on creating more vehicles, more options for the audience to buy. And then we slowly move into this transformation, I think.
Absolutely all right, sir. Those who want change with the time finally eventually changes them. So basically, it's a time when change is required in the sustainability. And while making the things more similar, like we are having in the ICE engines, the performance, the like speed and everything. So right now, the people in the market like you, who are the young industry leaders, are basically trying to make the positive changes which helps the sustainability also as well as the consumer demands of maintaining the proper performance and everything. So definitely it's a leading step from the industry itself. So basically, sir, in all this industry operations, we found out one thing, especially for the students, because today we are conducting the sessions only for the students community so that they have a proper insights about the industry. There is a kind of skill gap between the academia and the industry. Students are not so skilled as per the demands of the industry. There is a kind of a huge skill gap. So upskilling is something that is very important, sir. That what we believe. I would like to know your opinions on upskilling so that the students who are watching this conversation will understand this thing and learn from you, sir. So kindly throw some light on this thing, sir.
Okay. So here, I think more than students, industry and academia basically need to work together if you want to upskill the whole students who are coming out of the industry right now. Sorry, academy right now. So there are some partnerships that are going on between different industries and academia in having students get an internship so that they have a hands-on experience in an industry application. So this is missing in our academia right now. It's more of memorizing to clear an examination. It's vital to know the theory. Definitely, you need to understand what the theory is. But at least in the exams, we should not be asked the theory. We should essentially be asked a practical case scenario. And different students would have different answers, and there is no fixed answer. And this is the sort of teaching mechanism that different countries actually follow. Some of the Nordic countries and Europe essentially follow this sort of testing method. They do not ask you to memorize the whole chapter and then regurgitate it in the paper. Instead, they ask you specific case scenarios and they ask you to come up with a solution. And they will ask you why you came up with solution. You could have thought of something completely wrong, completely irrelevant, and it would not be practical. But they are still checking you whether you understand the concept of implementing this one. If you understand that one, then you're graded based on it. You understand that concept. Maybe your thought process was not very correct, but the concept was somewhere there. And for this, academia and industry both need to be involved. And then you have this training programs from different private players who are giving EV programs, EV training programs of different durations. But one thing that I want students to take utmost care in those is make sure you have hands-on. You have hands-on with whatever software you're working with. If it is software, it's not enough that they show you the software, they show you the model or simulation or creating a part. No, you need to do it. You need to have hands-on with that software. You need to understand how to set it up, how to run the process, how to see the results, how to report the results. This information is to come from you. Industry is expecting you to do this task. So seeing that is not enough. So most of the programs that I've seen in terms of upskilling students have stuck to giving them the theory. And this theory you can find from Google. You don't need an upskilling program for this. You need an upskilling program which should essentially be like the polytechnics and the diploma colleges, essentially giving you a hands-on. into how it is done. So that's what I think it should be done. Zitto is part of an incubation facility called Trust Research Park. So Trust is essentially an industry academia collaboration between CET, College of Engineering Trivandrum, and Trust Park. And there are several industries who are located in Trust Park, from soda boat, motorcycle manufacturing, you have auto rickshaws, EV auto rickshaws, you have semiconductor developers. So students get to spend a significant portion of their third year and the final year working with the industries, gaining knowledge, either getting absorbed by the same industry or getting out with enough information and knowledge and hands-on experience to get into the next industry. So this is not exactly up to students to fix. It's something that our syllabus and the academy and the industry basically need to reform.
Absolutely all right, sir. Because the hands-on training is something that is very, very important right now, and we at Industries Helping Hands is trying to bridge the gap, because until and unless the student has not seen the part of the electric vehicle, until and unless they are not having the experience of what the things are working, what are the components involved in it, and how they work. So basically, curiosity is something that will be missing in the whole entire system. So we are trying to bridge that gap. And apart from this, let me start from the beginning itself, because whenever any student starts their placement preparation, first thing that comes in his mind is the CV and or resume preparation. And in that blank paper, how they have to show their personality is something that is challenging for them as a student. So basically, sir, I would like to know your opinions on it. How a student should have to make their resume, and what are the things they have to keep in mind while making their CV. And second part of the question is that, as you are already the CEO of the company, so what are the things that you are looking into the student CV? Because hiring is one of the operations which gives you the highest ROI in compounding. So these are the two kind of questions I would like to know from you, sir. First from the student perspective, and then second from the recruiter perspective, so that student will understand the things behind both the things.
Okay, yeah. So, yeah, recruiting, every recruiter must be going through hundreds of, maybe thousands of CVs. So, recruiting is very vital to any company. And often candidates get rejected, not just freshers. In general, candidates get rejected just because they couldn't stand out from the crowd. The CV is nothing special there. It's all the same format. You have the same set of wordings, and it just doesn't stand out. So CVs are essentially your first impression that you can make to a company. You're not meeting anyone first. You're essentially sending the CV and expecting them to have a picture of you as a person. So make sure that CV stands out. So from my experience, what I've seen is there is quite a lot of irrelevant information. I cannot speak for other companies. I would speak exclusively for us. I see a lot of irrelevant information inside CVs. So I've seen people write caste name, religion, father's name, mother's name, marital status. I do not know how any of these things are relevant to the job you're going to do. It's sort of like filling the space. They just want to add something so that it's sort of filled up. And you have to understand that a decision from any recruiter, not just us, any recruiter is done in seconds. So you have 6 to 8 seconds to make a no-go decision. No-go is a rejection decision. The decision to go forward takes a long time, but decision to not take a candidate happens in 6 to 8 seconds. And in that 6 to 8 seconds, no one is going to read the entire CV. That's not the point. They are going to look at specific areas of the CV. And this was done in a study. So they have shown exactly which all points a recruiter would essentially look at in a CV. And this takes 6 to 8 seconds. So in that time, if you can't impress, or if your relevant data is not coming in those regions, you already lost a chance. So as an example, I would say, think about a juice box. You're at a supermarket, you want to buy a juice box or a juice bottle. You are gonna go through a lot of juice boxes and bottles there, and imagine you are health conscious. You want to see the ingredients in those. So essentially, you take one and you look behind. There is so much written on it. There is so much certifications and so on. But you look at very specific things that are relevant to you. Straight away, your eyes will go to ingredients. You find this sugar is X amount and cost is X, and you're done with it. You can go to the next fruit box and you continue this same process until you are happy with one of them. So it is exactly what um, CVs go through with a recruiter. They essentially are looking for these vital pieces of information. So if we can push these, then you have a better chance. And freshers, one advice I would suggest, I would give to you is to retain your CV size to 1 page. So even for experienced people, it's possible to keep CV in a page. You don't have to keep every single work that you've done in the past. You can essentially keep what is relevant for that job you apply and keep it to 1 page. I've seen students keep 1 page of CV information, then there is another additional blank page. So they have not even formatted to make sure that there is 1 page. There's only 1 page of information. And once you're done with your CV, read it 10 times, correct the grammar if possible, correct the spellings if possible, and then you give it to a second person and ask him to check it. Ask him what catches their eye. Is my last designation showing up? Is my project experience showing up? And this second glance will help a lot to improve your CV. And if I am the second part of the question, as a recruiter, what I'm looking for, I usually go straight to their project. The first thing I look for is have they worked in any SAE projects, Baha or Formula Student, anything like that. If not, what was the project they did? And usually I see a lot of students fail to take up challenging projects. There are so many identical projects that industry usually doesn't even look at right now. One of those, I can say an example is the line following robot. I see a ton of these. Industry already has line following robots. There is embedded magnet following robots. We have AI based robots which can do the whole process without even lines. And still students are stuck with the line following robot. Is it because it is easy? I do not know. But they are not picking up the real challenging projects. Even if you fail in the project, it doesn't matter. Pick up a challenging project and go ahead with it. The end result will show. And then I see CVs with the declaration at the end mentioning all I mentioned is true. We have a signature. I don't know. I don't know why it is relevant. I don't know if any company is looking for that. When you write in your CV, it's supposed to be true. There is no need to have a declaration saying it is true. You can just write the CV, and the companies have a method to identify whether what you've written is right or wrong. They will have HR interview, they'll have a technical interview, and you'll have to answer to all these things that you've written there. So they would have different ways to identify whether it is true or not. And then you have the wrong channel of communication, which is another problem. So if a company has asked you specifically apply via our website, do it. At that point, even if easy apply is available in LinkedIn, don't click it. Take that extra effort because that counts. The company will actually take notice, and do not spam all the hiring posts. So this is something that I see quite often. Someone has applied for mechanical, electrical, electronics designer. So it sort of says that you are not sure what you want to do. So that's an instant rejection. So don't do it. And if you're writing your CV as a fresher, give focus to your projects. Internship projects, if you have something, you can put it, or your college project, put priority to those projects. Your course, if you're studying mechanical engineering, everyone studied mechanical engineering. So that doesn't make you stand out. But your project is exclusive to you. So maybe 5 people else otherwise did the same project. So it's very exclusive to you. And so try to put priority on it.
Absolutely all right, sir. The way you have told the things, whenever we are going to buy any product, we see some of this, we are not able to read all the things that is written on the packet of the product, but definitely we see some of the specification that is important. So I would say to our student community, while you are making any CV, it's the first ingredient of your recipe towards finding a job. So make it in a way that sir has already explained in a very proper way. What are the things that you have to maintain in your CV? So my second question is that, sir, as you have mentioned about the projects includes the Technology is also. So I would like to know from your end, what are the technologies that students right now should have to work on it, or they have to make some projects on it so that they can have the opportunity in the EV industry, which shows their skills that they have worked in their student life and now they are ready for the job opportunity. So what are your views on it, sir? What are the technologies the students should have to work right now for the EV industry?
Okay, this will be hard to answer actually because project is very subjective how you do it because even a very simple non-related to EV project could end up being very relevant to it. For example, composites doesn't sound very relevant to EVs, but in terms of making the battery packs, the weight of the vehicle down, composites play quite a significant part. So it's not very cut right. You can say, okay, this will be relevant for EVs and this will not be. Rather, I would say a few trends or some technology research areas that are popping up. So one of those is in terms of EVs is supercapacitors. You have bidirectional charging. You have off-grid solutions. So solutions where you use solar charging or a wind charging, wind energy generation, hydro, and so on to charge an electric vehicle. You have wireless charging technology, which has quite a lot of limitations right now with losses. There is significant amount of heat generated. So industry is trying to solve those issues, get a better solution because wireless charging is eventually where we are headed, I believe. You have ADAS, that's the advanced driver assistance system. So most of the work, I think India is already starting to see introduction of ADAS. Tesla has a level 3. You have so much potential for level 4, level 5. So that is an area of interest for the industry definitely. And then you have road electrification. So in countries like Germany, wherein when a truck comes to the highway, one of the lane is completely electrified. So you can use a pantograph from the truck and run the truck as an electric vehicle until unless it's leaving the highway, it's electric. So once the last mile is done using ICNG vehicles and the road is basically electrified. So these sort of things could be definitely evaluated. And then you have rare earth removal from water. So this is another key area there where industry is focusing on. There are some companies that have already come up with some solutions because the magnets and the rare earth elements that you use in the motor are very expensive. And to avoid this, many of the EV startup companies, what they have done is they use the older technology, like the induction motors, AC induction motors, and which does not need magnets, but those are inefficient. So if you can identify a way to improve the motor without these magnets, yet keep the same amount of efficiency, so there is a definite improvement there. Then you have algorithms for everything. So you have the motor controller algorithm, you have the BMS algorithms, different VCUs that you can work with, control units that you can work on. So these are some technology areas that I see happening. And then there is, in terms of lithium-ion battery or battery itself, not just lithium-ion, two methods are considered to be how we would improve battery packs. One is better batteries. So definitely use of different materials to improve the battery. So we already have a production of graphene batteries now. There are batteries like nanovolt lithium tungsten batteries. We have organosilicon electrolyte batteries and gold nanowire gel electrolyte batteries. So many battery technologies are being worked on. So these are variations in different cathode anode configuration, different electrolytes to get a better battery. And then the second method of improving it is packaging. So if we can identify a way to package the batteries better, so there is a possibility of improvements in batteries. So this is a region where people can work on, and I think there are a few companies within India who have worked on using different material for batteries, coming up with different solutions in that way. And a research program project, even if you're doing a project for your studies, make sure that you keep the economics and practicality of it very clear in your mind. You need to make sure that if you make something that it's like a one-off, there is no way you can scale it up. There is no way industry can make this used in a practical scenario. Then there is much less application. I'll come back to the composites again for an example. So imagine you're making a composite. At some point, this actually happened. So there was a composite made with chicken feather and mixed with, I think, polypropylene or something. And it sort of was a composite which could be essentially be used for automotive industry, is what they said. So don't know where it went, but if there is sufficient economics and practicality study done on it, then maybe we would have seen it. And the same applies for several such composites, different leaves blended with different materials to create composites. And these are all good in terms of how to finish off a research project. But for an industry application or an EV application, we have very limited access. That's because it's not economically viable. So when you're doing a project, no matter what it is, my suggestion would be from the very beginning, ask this question. Okay, I'm developing this now. This is at lab stage. 10 years down the range, I want to bring this product to the market. So can I do it? Do I have sufficient resources, materials available in the industry? You don't need to be able to capture that resources, but at least check if it is available in the industry, whether you can get these resources to make this practical. Can you make this product come to the market? So this question, if you can ask from the beginning to end, I think you'll have a great project.
I completely agree with you, sir, because batteries are the heart of the electric vehicle. So the students should have to give more importance towards the batteries by learning them and finding the alternates also. So basically, sir, I would like to have some few questions from you. I would like to ask Mr. Ashish Kaduskar. Basically, Ashish, sir, you are having the interaction with the students. Lots of students come up to you and ask so many questions related to the technology and the different aspects of the EV industry. So I would like to like say whatever be the questions you are having, please ask with the Chandan sir because he is already the knowledge bank of all these things. So yes, please continue, Ashish sir.
So yeah.
Okay.
So before going to the technology part, first I wanted to ask that many students have that perspective that this EV industry is mainly for the mechanical and the electrical engineers only. But they totally ignore that it is not completely for the mechanical and electrical. It's a blend of all of the engineering branches, especially the computer science also. So I wanted to ask you that how each and every branch that is I'm talking about from the engineering point of view that it will impact in the EV industry from because the mechanical is important, electrical, electronics, and especially for the EV industry, the software that connecting the grids and the vehicles to your mobile phones and the whole tracking systems that is available now. So how each and every engineering branch of it is impacting in the EV industry, I wanted to know from your perspective.
Okay. In terms of mechanical, I would say it's not very different. When it comes to an EV or an IC engine vehicle, or even most products, the mechanical aspect of it is almost the same. You're working with the same set of materials. There is no grand innovation that was done like that. Exceptions are there. We have some better tools now. So in terms of finite element analysis, we have tools like topology, parametric optimization, generative design. So the computer is doing half the task. But the common logic, the basement of it is still the same. It doesn't matter if you are using it for EV or IC engine vehicle, it's almost the same. Yeah, now a few more things that changed in the EV industry is like, for example, crash safety. So earlier, crash safety used to be important for the IC engine vehicle because of passengers. So you want to protect the passengers. Now, adding to the passengers, you basically have to protect the battery as well because there is possibility of rupture, you have a fire possibility, you have some sort of ingress that could happen. So you had to make sure that the passengers are safe from both the battery and the crash itself. So crash safety has become, so there are different software platforms which can perform this sort of crash simulation essentially and tell if the casing you have designed is good enough. Then I would say in terms of mechanical, it has always been like this, but now there is an extensive focus on simulation. And simulation has essentially become the core of mechanical actually. The FEA, the CFDs, the thermals, fluid flow, aerodynamics, it's all done in simulation. You perform once in a while validation, confirming and converging the information, just confirming that your model is performing right. But most of the work now is done using simulation. When it comes to computer science, I think there is ample opportunity in computer science. So there is UI design. So most of the workers now you have displays that show you navigation and speed and telemetry and so on. So you have that to work with. You have the IoT devices which connect the vehicle with the grid. The keys are a keyless entry, and we have so many things that are connected within the EV and outside with your phone and so on. And then you have AI, which is again becoming a buzzword in terms of development in EVs. And like I mentioned earlier, ADAS is also becoming a big part where computer science could have big implementations. And then there is general application development. So you have phone applications, you have application for your websites, you have different ways of showcasing, even in sales, marketing, you have a requirement for computer science engineers to develop how the whole system works, because everything has gone digital nowadays, especially after COVID, everything is remote and digital. So computer has quite a lot of application. And then you have security systems for the EVs, because imagine most of the EVs right now have a phone-based unlock. Imagine that being cracked by someone, so essentially rendering it useless. So you need security systems to be checked. Then you have simulations. Again, simulations play a big part even in computers. For electrical, one difference between the IC engine vehicles of the past and the EVs right now is the requirement of having two architectures within. So there is one high voltage architecture, which is essentially the powertrain, that is the battery, motor controller, onboard charger, battery, motor, and so on. And then you have a low voltage system, which is essentially taking care of the headlights, the tail lamps, and the indicators, and all the smaller systems. So that is one difference that we have. So they need to know how to handle this high voltage. So learning about this high voltage system, safety of high voltage system, how to develop, and what are the standards that are involved in high voltage systems, and the general development of these systems. For example, the standards like ISO 26262, those sort of standards or standard practices to follow for working on electrical system. And then you have motor development. So different topologies you can work with in electrical. You have harness development, because harness is a very important part of high voltage system. So you need to know how to develop it so that it creates minimum failures and minimum resistance while you're connecting all the devices together. In terms of electronics, we have, I think that's a core difference where EVs are playing right now. So you have BMS, motor controller, you have VCU, onboard charger, you have charge port. Each vehicle, each manufacturer have a different requirement for this. So, and most of these systems have an AI capability. There are redundancies that we develop into the hardware of it. So in terms of electronics, you have quite a lot of change from conventional IC engine vehicles, because most of the components used to be analog or purely mechanical. Now we are seeing quite a lot of implementation of electronics into it. Even systems like the braking system it's completely electronic now. So drive by wire, brake by wire, those sort of things. And then you have communication based subjects. So wherein communication with the vehicle, communication to the phone, communication to the cloud. So wireless communications are very vital right now. And inside the vehicle itself, you have multiple communication protocols that you can follow, SPI, CAN, etc. So understanding all of this, if you know these technologies, essentially you can meet the demands of the EV industry. And there is significant demand from the EV industry for talent right now.
Okay. So, and there are some future technologies that yet to come in the EV industry that, as you discussed about the bi-directional charging technology, what we say V2G.
Yeah.
As of now, it is G2V, but there are technologies which means there are companies who are working on V2G technology.
Yes, yes.
How you will means how you say that it will give a greater impact in the EV industry, because that's a very unique thing to have, that your vehicle is powering your grid or your house.
I think again this is a systemic situation, so it's not enough that a manufacturer is providing this capability. Your personal home, for example, if it's your home, your grid need to allow you to do it. So then you have to talk to your provider, your service provider. They need to agree to this. They need to put a different meter for this, different converter or whatever is required. And that whole process is not just from the EV side of it. EVs can have the capability, but how you utilize it is quite a lot dependent on how your service provider allows you to. I think most of the service providers have already started to allow for solar charging. So you have a grid-based system which essentially creates solar energy, provides it to the grid so that it augments the demand supply issues, and they pay for that. So X amount of money per unit of electricity that you're providing. And when you use it, they subtract it from that one. And then there is almost completely off-grid systems wherein your solar energy can be used to charge your own battery packs and use it in conjunction with the grid power and use it for that one. So you need a third system for this to work. So you're essentially sending energy from the car to the grid to essentially, if you have a solar, yes, you are taking it from the solar to the grid. There are so many ways you can route it. So your provider, if they are not willing to take this up, they are not giving you the permission to operate it, then you have a problem. But I think with legislation, it's definitely possible. It is a possibility that we can explore.
Yeah. And there's one more topic that that people will debate about. That is the battery swapping technologies. Means the battery swapping stations. That it is good or it is bad, because you have your completely new EV, and you go to the battery swapping stations and you swap with the different battery, and it may be possible that you will get older batteries than what is yours. So, what is your view in the battery swapping technology systems? In
Okay, let's say, I personally believe the future of charging is high-speed charging and home charging. So you're going to do two things. One is you're going to charge it really fast at a rapid charging solution, or you're going to charge it at home. And almost 90 to 95% of people do home charging already. Like if you have an EV, there is less chance of you actually going to a public charging station and charging it up. And there was one interesting study that I've read wherein they mentioned the amount of infrastructure which would be needed for a single manufacturer if they went ahead and made charging stations for all their vehicles throughout the world. And it's a massive number. I don't think any company can do it standalone. That's why even companies like Tesla provide adapters so that even if their own grid is not available, you can charge it from any of the conventional grids. So that is the direction that we are essentially going. So every every vehicle will eventually come with high-speed charging. We already have vehicles that can charge at 10 minutes, near about 10 minutes. And with future technology, I think it would definitely be coming to near about 5 minutes. And the range is already exceeded 150 for motorcycles and 200, 400 plus for cars. It's only a matter of time before it's reaching the 600 mark, and for motorcycles the 200, 250 mark. So at that point, do you essentially need swappable batteries? I do not know. So we Zitto and Trustpark are part of the NITI Aayog committee for the Open BMS project. So one of the standards that we recently saw from BIS is regarding the swapping batteries. So they have specified some dimensions and some specific connectors to be used. So if you are one of those manufacturers who are using swappable batteries with a different connector, so how do you fit the picture? So this is a question that I've always had. In terms of number of batteries that need to be kept at a particular charging station is also a big question. So imagine it's a very high traffic region You're coming with your vehicle and the batteries are already gone. So if a vehicle has 2 batteries and the charging station has 10 batteries, 5 people came and went, means you are essentially charging your batteries there. You're charging your vehicle at the charging station. So is it really a plus point there? I think it's a bridging solution for now. For the time being, swapping makes a lot of sense. And for applications like bicycles, smaller electric powered bicycles, it makes complete sense. You do not need to take your bicycles up to your room. You can take the battery pack and charge it in your room.
And for the four wheelers, it is more. It is not feasible to swap your battery in your four wheelers.
I think Neo is already doing it.
Yeah,
And,
yeah,
Tesla actually did this and then abandoned it. And I think there was one company based in Israel which got completely shut down because this did not make any sense. The infrastructure required for swapping a battery is massive, and then you have to hold X number of batteries considering all these workers are going to come. And then there is people who would not want to do this. Indians consider vehicle as an asset, and that includes a battery pack. So if someone has driven it very gentle, calm, and they get to change the battery, and suddenly the performance is nowhere near what they thought of, I don't think it's something that they would want to see.
And that's my question from my point of view to the CEO of a company, Zitto Motors, that here in India there is a lots of vehicles which is coming from outside of this country, mostly from the China, and their charging technology and the charging guns are of different, because there are the supply voltages are different in the different countries. So in India there are lots of EVs which have different charging guns, means CCS2 and the CHAdeMO and GBT, which is for the from the China, and the vehicles from the Japan they uses CHAdeMO. And there's a lots of means confusion in the for the customers that there are different charging guns for the different vehicles. So from your point of view, so which charging guns that, because there is no standard as of now for the charging guns also.
Okay, so this I think I would have to take the example of Europe. So if you look at Europe, it's CCS throughout Europe. So they made it mandatory that every vehicle come with this charger. So this made Tesla give their vehicle a CCS charger. And China did the same with Tesla. So Tesla has 2 ports in China. So one for their Tesla fast charging solution, and then one for their Chinese solution. India is India is going through what we did with the charging cables of our phones in the 2000s, with the multiple chargers from Nokia has one, LG has one, Samsung has one. And someone had to come up with a standard and say like, okay, everyone stick to this one. And then it, for a long time, it sort of happened and everyone sort of stuck to it. Now the revolution is happening again where USB-C is becoming the standard. So this is legislation that the country has to make it stand clear. It's not enough that they let companies choose what works for them, because then they'll choose the easier direction to go with. My personal perspective is this: that imagine you're going to Indian Oil to fill your car, and they are saying, okay, you can fill your vehicle only at Bharat Petroleum because our nozzle is different size. Is that how you want to develop a charging infrastructure? I don't think so. I think it should be universal. Like everyone should be able to connect to a single charging unit and work from it. CCS offers quite a lot of flexibility in terms of AC charging and DC charging. It has been pushed to really high limits of 40 kilowatts, 400 kilowatts plus and 800 volt plus have seen for Porsche workers, you basically have these sort of high charges. And all of them basically essentially have the same set of the principle of working is almost the same for all of them. It's just a different size connectors, different connecting methods, and different communication systems in between. But it's possible that we can bring this to a unified charger, and I think government will eventually take a decision and say like, okay, stick to this one.
Yeah, because there is a standard that AC001 and DC001, but it is not made a mandatory for all the manufacturers.
Yeah, it has some limitations which is not very conducive for everyone to use. So that's the reason that not everyone want to take up that one. And we already have charges. CHAdeMO and CCS charges are being implemented by different charge providers. So if you already have an infrastructure in place, would you modify it now, or would you try to augment it? That's a question.
So, last question from my side, that there are some technologies, the research is going on in the battery technology, because lithium is in means it is came from the mining, and it is in the limited core in the in earth. So, what are the future technologies that you think that they will replace the lithium batteries? Because in India also there are some manufacturers which is moving forward in different battery technologies, just like sodium ion batteries, solid state batteries, and fuel cell also. And which, from your point of view, which batteries is more capable of replacing the lithium ion batteries?
I think from my perspective, I would say whichever is available makes a lot of difference. It's not enough that there is a battery available in the lab. It's another 10 years from getting to your hand. So there are some technologies that we already have hands-on. There are some technologies that are already born into production. So this is of interest. Everyone is researching something brand new, silicon or some other type of anodes, cathodes, and electrolytes. But where are they with production is a question that we often ask. Because if you can't put this on the vehicle, say 3 years from now, how is it valid to create a vehicle based on that? So what is available in the next 2 to 3 years is what we should essentially take as a good technology to go for. And that's what every company is doing. So most companies went with lithium ion initially because it was available in plenty. So many manufacturers were making the standard form factors 19650s and 21700s. Now they are sort of evolving into different chemistries, different sizes. So Tesla is evaluating a new size and new shape of battery. They are doing a different chemistry of lithium iron phosphate. You have cathode batteries with different design direction. BYD has a different design direction, but the same lithium iron phosphate batteries, which are safer, which offer some additional cooling advantages. Some penetration test results are really promising. So my suggestion is go with what is available and what is better at that time, because there is no point in saying like, okay, this technology is being worked on, so let me develop my vehicle for that technology that might or might not come. That doesn't make enough sense.
Yeah, because the cost of the electric vehicle is totally dependent upon the battery.
Yes,
And
yes.
batteries increases the cost. So the manufacturers are also wanted to reduce that cost, because the batteries are mostly coming from the import from the our other countries, mostly
Correct.
from the Chinas.
Yeah. Chinese players have at the forefront of getting providing the cheap cells, or the cheap cost cells essentially come from China. There are some really good cells from there as well, but most of what Indian companies utilize are the low cost cells, because selling a vehicle at below 1 lakh you cannot do with a really good branded cell. It's just not possible, because each of those cells from say the Korean brands or the Japanese brands are extremely expensive. They might be great in performance, but cost wise you'll hit the limit with those. So then essentially at 1 lakh you are providing just the battery to the customer, so that makes no sense. So people have to compromise and pick a cell which fits their budget, and that's the direction that we are going right now.
Absolutely correct, sir. Whatever be the points that you have tell the students, each and everything right from the scratch about the industry insights related to battery and the other components, it's really very valuable. So at last, sir, I would like to know that what kind of advices and suggestions would you like to give to the students? Because I really understand that when you were in your student phase, you have also faced all these questions where you need some kind of guidance from the people. So the student community is also now looking for the same. They are in the student phase of their life and they want to know some guidance from you, sir. So kindly guide the student community across India so that it would be helpful for them.
Okay. So I would tell you a fact about the industry right now. This is one of those rare opportunities where 20 years of experience in an OEM, in an IC engine OEM, and 3 years of experience in an EV almost would be make you equal in terms of joining the EV industry, which is a weird time, but that is a fact. So try to get into try to take up any opportunity that comes to you for learning instead of trying to settle immediately after your studies. Most people want to just get into any sort of job and not even related to what they have studied. I've seen students finishing mechanical engineering, then abandoning the whole logic and dream of being a mechanical engineer, and then going behind IT and getting the job. They work for a few years there. By the time they got settled in that one, they basically cannot escape. They are stuck there. They essentially do not remember what they studied as part of mechanical. And essentially from that point, coming back to mechanical, identifying a job becomes very tedious. So what they do is instead they follow that journey of as an IT professional and do that job there. So yeah, this is one direction that I've seen people do. So don't do it. Instead, rather, even if you can't get into a stable income, try to gain as much knowledge as possible in the 2 years just after your studies. It wouldn't hurt you. Like that growth you can gain in that 2 years would take you to a next level. If you get a campus placement in an engineering job, in a mechanical job, or whatever subject you studied, great. You work on it. You work your way up from there. But if not, do not jump into the first job that you get. Identify the job that you essentially want to eventually get into and stick to it. And in general, what things that I would like people to study or do and when they are doing their studies is essentially work on projects. So if it could be your college project, if it is that time consuming, focus on that one, have it really good. If not, there are so many people who got into who are unfortunate to be in really bad academic projects that they couldn't do well or that did not gain anything for them. So take up really challenging projects from now, and then everyone need to know a set of let's say softwares or knowledge or skill set that industry expecting. So I would suggest everyone to learn MATLAB, Simulink, AmSim, these sort of simulation softwares, MATLAB Simulink especially. And if you are from a mechanical background, CAD is considered not as an asset. CAD is essentially like saying, I know Microsoft Office or Excel. That is not exactly an asset for any employee right now. So you are supposed to know this. It's like everyone knows how Facebook works. So it's not a great thing if you have a profile in Facebook. So CAD knowledge you essentially have, and it could be any software. It need not be on any specific software for industry use. Based on different industry use different softwares. Learn one which you are comfortable with. If you have to switch between another CAD software, it's just a matter of learning. That there is a little bit of learning curve involved, how the tools are used and different keyboard shortcuts and so on. But in 2-3 weeks time, you will be up to speed anyways. And if you want to go one level further, look at GD&T certification if you want to. That's a good thing to have on your profile. There is a new trend of additive manufacturing, so 3D printing, and it would be great if you can talk to any of the 3D printing. There are so many 3D printing companies in India right now. So if you could talk to them, ask them for like 2 weeks of internship in which, or just to see how they do the process from CAD to conversion to the step file, or how they print it and what process they use and why they use that process. What the surface finish is, how to finish off the product completely, how to create a support structure so that the printing doesn't fail, these sort of questions. So identify this one. This will add in your CV as a really great thing. And Then, in terms of mechanical, learn FEA. You have to know FEA really well. It could be ANSYS, softwares, Altair, Console, anything you want to learn. All of them basically do the same set of activities in different ways. Learn about different optimization strategies, topology, parametric, generative. So, for example, generative design is where you set your boundaries, you set your limits, you tell the system these are the regions you can modify, these are regions you should not modify, and then you tell the system what are the limits, what are the loads, what are the parameters, and then the system generates a number of models automatically. And from those models, you can identify what model works best for your specific scenario based on cost, based on manufacturing technology, whether you want to 3D print it, whether you want to CNC mill it, and so on. And then you have CFD, so fluid dynamics, thermals, fluid flow, aerodynamics. These, again, as part of FEA, it would be great if you learn one of these, any CFD softwares. And if you're interested in vehicle dynamics, you can look at Altair suite of softwares, Hyper, Motion Solve, or Lotus car maker, and so on. There are so many softwares. If you are from an electronics background, I would say know how to simulate circuits, analog, digital, eSpice, LT-Spice, Eagle, AutoSAR. Then you have the PSIM and so on, and have a really good understanding of power electronics. Whatever you learned in theory, you better have a good grasp of it. If you are from computer science background, the new buzzword is AI, but AI usually people associate only with machine learning, but it's not just machine learning. There is neural networks, robotics, fuzzy logics. You have natural language processing. So if you want to go in that direction, you can look at softwares like TensorFlow, Python. Then you have so many industrial softwares which you don't need to go for, but TensorFlow has several sub-modules within which you can explore. Even MATLAB has some modules which you can utilize for AI. If you want to go specifically into a battery, you try to do cell modeling, model-based design, try to understand some of the standards that industry follows, why that standard exists. And if you want to go as a vehicle designer, then I would suggest areas, Blender, Photoshop, those sort of things. And in effect, the entire vehicle runs around simulation. So if it is electrical or computer science or battery, whatever it is, there is a pathway for simulation to go on. So you can basically do mechanical simulation, electronic simulation, computer simulation, battery simulation, and so on. So you could essentially explore pathways in those as well. So I think these are things that would help you get placed if you are off the college and you are still searching for a job. And do not stop doing projects. So this is one thing that I would like to tell you is that once you're done with the college, do not keep your college project and say like, okay, I'll just apply for job after job, hoping that something comes up. No. While you are waiting, I would suggest you pick up projects. If you're from electronics background, you make a one cell BMS or a small controller, or a power converter, amplifier, motor, whatever you want to build. Take up robotics if you want. If you want to do simulation, you can do cell modeling, you can do vehicle modeling, controller modeling, you have BMS modeling, charger modeling, and so on. You can model all these things. There are so many resources available in YouTube and in the open Google and so on. If you have a mechanical, you essentially design a part. You start from the concept, you draw sketches, you convert to CAD, you do the FEA, CFD, and then you do DFA, DFM, DFS. So these are designed for assembly, manufacturing, service, etc. So you bring this sort of thought process into whatever project you're doing. And if you post it on LinkedIn, like whatever great projects you're working on, post it on LinkedIn, someone would see this. If it is interesting enough, you start conversations with those people and probably you'll end up there. So either an enterprise will take you in, or with these projects and experience, you become the enterprise. So the two directions that you can essentially go to. And most important, I will stress this again, be open to opportunities to learn. If you get an opportunity to join a startup, to join any company for an internship, someone is asking you to join a project and you make no money of it. So your friend is asking you to join him in a project. He wants to do a startup. He wants to do something. Go on with it. It's much better than sitting and using your CV and sending it everywhere. You can gain quite a lot just by working with that person in that particular project.
Absolutely correct, sir. In this conversation, like you have explained everything and you have covered even almost all the student because student itself are diversified into the different streams. But the way you have covered the things right from the beginning, whether it's from computer science or IT engineer or mechanical, electric or electronics, you have covered all the things in a very proper way. So thank you so much, sir. This is one of the best session I would say we are having because you have covered the things in a very proper way right from the beginning. It's like you have explained the things in a very proper way from CV to the whole curriculum. So it's a very, very good session that we are having with you. So thank you so much, sir. And one thing I would like to say that I personally learned from your journey is that thinking big requires the same number of brain cells as thinking small. So you have to think bigger in your life the way you does. Right after all the education and everything, you have started the things on your own because of your pursuance to learn everything. So, and second thing is that, sir, time is the most precious thing that anyone can give to anyone. You have shared your knowledge and give your valuable time to us. It means a lot for us, sir. Thank you so much. Thank you for conducting the session for the student community across India. Thank you so much, sir.